Good day. We are Likop and Patalinghog from the Department of Mining Engineering. The title of our presentation is Application of Mineralogical Techniques in the Assessment of Potential Health and Environmental Risks of Nickel Laterite Mine Silt. To start, the current practices in assessing potential environmental risks in the Philippines are done by water testing or dust pollution through chemical tests and are usually done outside the mining site's premises already. Mineralogical analysis like X-ray fluorescence or XRF and scanning electron microscopy or SEM with energy dispersive X-ray analysis or EDX can determine the elements present in samples like soil and plants, including the concentrations of the said elements. Part of the many requirements to be able to start a mining project is to have and secure siltation ponds, where mine waste undergoes settling or sedimentation. When these elements would have high concentrations, it would result in the decrease in the microbial community and loss of soil functions. And storing high amounts of these elements in one place increases their poisonous quality, and their non-biodegradable characteristic alone makes them remain in the environment for a long time. 3 kilograms of samples were taken from each siltation ponds, to name the PY Alaan, the Area 9 Mantiawas, and the Area 3 North by Ambis Mines Department. The nickel laterite silt samples were collected from ponds at areas near bodies of water. The samples were then prepared by Ambis Assay Department through oven drying at 105 degrees Celsius. All three samples were initially dried for 12 hours and were dried continuously until all their constant weights were achieved. All three of the nickel laterite silt samples were then analyzed, but due to financial restraints, only two samples were subjected to SEM-EDS. Samples from PY Alaan and Area 9 Mantiawas were sent to NASAT Labs Laguna for SEM-EDX analysis. Based on the results of the XRF analysis, iron is the single element with the highest weight percentage. Kindly also take note of how low the weight percentages of calcium oxide, potassium oxide, and titanium dioxide in Area 9 Mantiawas because these elements were not detected in the SEM-EDS analysis. Calcium, potassium, and titanium were detected in both spectrums in Area 9 Mantiawas through SEM-EDS analysis. Almost all of the elements are mutually found in both analyses, but only XRF was able to detect cobalt, phosphorus, and sodium, which all had very little weight percentages ranging from 0.02 to 0.07%, with oxygen, which is the reason why they weren't found in SEM-EDS. And only SEM-EDS was able to detect carbon, because XRF normally cannot detect elements lighter than magnesium, which is why it wasn't able to determine carbon, despite being determined in SEM-EDS with concentrations ranging from 16.06% to 24.46%. It was found that magnesium in the silt has concentrations of 4.57 to 7.3 times more than the permissible limit. Iron has concentrations of 1.2 to 2.3 times more than the permissible limit. Chromium has concentrations of 2.1 to 5.1 times more than the permissible limit. Nickel has concentrations of 88 to 194 times more than the permissible limit. And lastly, manganese has concentrations of 2 to 7.2 times more than the permissible limit. And even the United States Environmental Protection Agency standard for the maximum concentration of heavy metals in sludge, nickel is still 10.5 to 23 times higher than their maximum concentration, while three of the spectrums in chromium are a little higher than the set standard by 1.1 to 1.7 times. Heavy metals, such as chromium-3, which was found in all three samples through XRF analysis, has a strong hydrolyzing capacity, which decreases the pH of soil and leads to the change of elements, chemistry, and bioavailability. Also, iron still has high concentration, and the presence of iron sulfides in wetland sediments is one of the factors that increase the mobilization of nickel into groundwater during periods of drought. Determining the health risks due to the elements need more data than just the XRF and SEM-EDS concentrations. The effects of the elements on humans depends how much is ingested, which is related to their bioavailability, exposure, and pathway. In terms of workspace, elements such as potassium oxide, titanium dioxide, and magnesium were rated with serious, moderate, and slight ratings respectively with regards to health by the New Jersey Department of Health, and all three can affect one's health through inhalation similar with silicon dioxide, which may, which may possibly cause issues not only in the lungs but also in the kidney. To summarize, the current practices on the risk assessment, such as pH water analysis, applying SEM-EDS and XRF for risk assessment would be another method that could already assess the potential risks that mine waste could possibly cause, not only for water bodies and their bioavailability, but also for soils, knowing how heavy metals when localized become more toxic.